Hey, what's up you guys? Alright. Hey, what's up you guys? My name is Harrison and welcome to School of Swipe. So today we're going to be talking about polynomials, but actually complex numbers and a subtopic in complex numbers, which is polynomials. So here we go. Alright, so first of all we're going to do a little bit of a recap for quadratic equations. So if you studied quadratic equations, you would have learned this formula, which is x equals to minus b plus minus b squared minus 4ac over 2a. It's a mouthful. So and what you also would have learned is this thing called the determinant, and basically the determinant is b squared minus 4ac, and it basically tells you how many roots there are in this equation. So if this determinant is bigger than 0, it means there are 2 roots. If it's exactly equals to 0, there's 1 root, and if it is less than 0, it means there are no real roots, or usually they'll say there's no answer. But hang on, if they say that there's no real roots, it means that there's actually complex roots which are complex numbers. So finally we've come to the point where yes, you can be introduced to complex numbers and you should still be able to do square root on a negative number. So let's see what that looks like. So here we have a quadratic equation, which you may have encountered before, something like that. Well, okay, so it's quite similar to what you've done last time. So what you do to a quadratic equation is you take the coefficients of x squared, the coefficients of x, and the coefficients of the constant number, which in this case is 1, minus 4, and 8. And then we just put it into the formula and you get something on your right. So what we have is, okay, let's see. So minus b plus minus b squared minus 4ac over 2a. We put b in and we put a and c in. So yeah. So normally you would take a look at square root negative 16 and be like, no, you can't do that, and and you just stop the equation there and say that there are no real roots. Or you would have like subbed it into b squared minus 4ac and found that it is negative 16, and then you just stopped it and said like, there's no real roots. There's no answer to this, but now when you see a negative number, you should still be able to square root it. So what you do is when you see a negative number like negative 16, is you can split it up here, right? So negative 16 can split it to negative 1 multiplied by 16. So when you square root negative 1, you get your I here, and when you square root 16, you get your 4 here. So every time everything else goes as normal. So you put in negative 4 into b and it just becomes a 4. So finally you have 4 plus minus 4i over 2, and that becomes 2 plus minus 2i. And if you notice, it is a number. It is a pair of numbers. It is a number and it's conjugate pair. So in this case it's 2 plus 2i and 2 minus 2i. So it is the plus minus 2i is why you have conjugates. Okay, so when it comes to higher powers, right? So if a polynomial has only real numbers as coefficients, it has complex roots which come in conjugate pairs if there are any complex roots. So okay, so I'm just going to give you a positive example and a negative example. So the first example we have here is 7x5 minus ax4 plus 12x3 minus x plus 3. So when you look at all the coefficients in front of it, which is 7, negative 8, 12, negative 1, and 3, all these are real numbers. So when they have roots, which are complex numbers, they will come in conjugate pairs. Okay, so conjugate pairs means something like we saw just now, 2 plus 2i, 2 minus 2i. Okay, so something that does not have real numbers as coefficients probably you can't guarantee that they have complex numbers that come in conjugate pairs. So something like this, here we have a problem. We can see that this does not have a real number as a coefficient. It has minus 8i as a coefficient, and if we look at the constant term, we have 3 minus I as a coefficient, so no go. You can't guarantee that this will have roots that come in conjugate pairs, so you shouldn't make that assumption. Okay, so there's a kind of question where they will ask you to solve higher order polynomials given one of the complex roots. So we'll take a look at that. So usually they won't give it to you where one of them is not a real number. Well, the coefficient is not a real number. Most of the time they give you a a polynomial equation where all of the coefficients are real numbers, so you should be fine. Okay, so this is an example, which is z cubed minus 8x squared, 8z squared plus 22z minus 20. Okay, so we are going to try to solve this. So given that one of the roots is z equals to 3 minus 1. Okay, sorry, 3 minus I. How do you solve this equation? So what we're going to do is, so remember, if I have an equation and I say that one of the roots is x equals to 2, so what I can do is, I know it can be divided by x minus 2, so I put bracket x minus 2. So we're going to do the same thing here. So z minus 3 minus I, which is what they said, and then z minus the conjugate. Alright, so this is the first thing. So this is the root. Oops, sorry. This is the root, and this is the conjugate of the root. Okay, so what we're going to do next is my favorite trick, is I'm going to expand the bracket and then regroup the bracket. So this thing happens, I'm expanding it and regrouping it. So when I expand and regroup it, I'll always end up with z minus something in the front of it. So what I can do is, so since I have something plus I and something minus I, we can use this formula, a plus b, a minus b equals to a squared minus b squared. Except that a is now z minus 3 squared, and then your b is just I. So we have this, and then I can easily expand our z minus 3 squared to get this. And then, so I squared becomes minus 1, and then we put it together to z squared minus 6z plus 10. Okay, so so let's just continue. So we have found, okay, we have z cubed and some other stuff as our first polynomial, as the original equation, and we have found 2 of the roots. So what we can do next is we can do long division to find the final root of the equation. So we're going to take z cubed minus 8z squared plus 22z minus 20 minus of this whole thing that we just found here. Okay, so that's the next slide. So okay, so the first thing we got to do is just write this out here and write this. So then we can put z up here, so that whatever comes up after here is, I'm taking z and multiplying it by this whole thing to get this. So so z multiplied by z squared is z cubed, z multiplied by negative 6z is 6z squared, z multiplied by 10 is positive 10z, and then after that I can take this and minus this off so that I have whatever is here, and then I do the same thing. So I see that minus 2, I can multiply that by z squared to get 2z squared, and everything falls into place and there are no remainders. So it shows us that our final factor is z minus 2. So we can actually say that z cubed minus 8z squared plus 22z minus 20 can give us this and this. So our final answer to the equation is, our final root is z equals to 2. So another way to do this, if you don't want to go through the hassle of long division, is this thing called observation. I generally do not like observation because it is, I just don't feel safe doing it. Like as a student, when I looked at it, I didn't feel safe doing it, but now I tend to be a little bit lazy. I like to do things faster, but it really depends on your comfort level. I don't think you should do this if you don't feel ready, but if you understand you got good grips, then you know, by all means just go ahead. So so we did the same thing as the first round. Let's say we found the 2 conjugate roots by multiplying the conjugate together, and we found this quadratic equation, right? So what we can do is, let's just write it together, which is this cubic equation equals to this quadratic equation plus this linear thing. So I mean, it works out because we have z cubed on this side, z squared, and just z on this side. So what we have is, we just say let it be plus b, and b can be any number. And then we realize that, you know, 20 and 10 and b. So the only way to get our negative 20 is if you get a linear, if you get the constant multiplied by another constant, and that's how you get this constant. So we have 20, negative 20 must be equal to 10 times b, and therefore we have our b equals to negative 2. So this is much faster. But yeah, I mean, if you just feel more confident or more comfortable doing long division, then by all means just go ahead. Okay, so yeah, what? So yeah, hence we have our final answer, which is we have 3 roots. It's a cubic equation, so we should have 3 roots, and the roots are z equals to 3 plus I, z equals to 3 minus I, and z equals to 2. And note that the two complex numbers are conjugates of each other. Okay, so finally I'm going to show you a way to do this with your TI-84. So here we go. So here's my TI-84, the emulator that is. Okay, so what I can do is go to Polysymbol, and then I can go to Polyroot Finder, and then I can go to A plus BI. It is very important to set this first, because otherwise they might just give you no answer, or just, you know, exclude all the complex numbers from the answers. Okay, so we have order. We are doing a cubic equation, so you should put it as, you know, 3. Okay, next. So what we were looking at just now is z cubed. So the first coefficient is 1, then the next coefficient is negative 8, and then after that is 22, and then after that is negative 20. And we can solve this, and we get the same thing as you can see on the PowerPoint slides. So yeah, yeah, that's it. So in the next video, I'll be talking about Argand diagrams. So yeah. Okay, so if there's any questions that you have, or anything that you don't understand, or you felt that I was going through too quickly, you know, just leave it down in the comment below. If you have any questions or any other topic that you want me to talk about, or just maybe something in general you want me to talk about, you can just leave that in the comments as well. So if you found this video helpful, please give it a thumbs up and subscribe to this channel, and I'll see you guys on the next video. Bye!